Okay, so welcome to part 2 of MOOC Math Calculus Intro. We are currently at question 6A in the Diagnostic Algebra test. So 6A, this is rationalize. Let's close the window. This is rationalize and simplify. So rationalize and simplify. 1 second. Okay. 6A is root 10 divided by root 5 minus 2. So to rationalize this, you gotta multiply it by it's referring to the denominator, which is the bottom of the fraction, because it's bad form to have a square root in the bottom of your fraction, but on top don't worry about that, at least for rationalization. So you're gonna multiply it by the conjugate, which is root 5 plus 2 divided by root 5 plus 2. So this is just multiplying by 1, and this will give you root 50 plus 2 root 10 divided by 5 minus 4, which is equal to 5 root 2 plus 2 root 10 divided by 1, which is just equal to 5 root 2 plus 2 root 10. And that's a fine answer, because 10 is a prime number. And you can't, if you take out, it'd be root 2 times root 5, and that's all you can do. You could say, you can take out root 2. It'd be like root 2 times 5 plus 2 root 5. So I don't think that's a improvement. So I'd say this is the final form you should put it in. Okay, 6B. How you guys doing today, man? Leave a comment. Hell yeah, let's do some math. 6B. So it's root 4 plus h minus 2 divided by h, which is, to rationalize this, you would I guess you cannot really rationalize the numerator in this case, so it doesn't really make any sense. But I'll see what I can do. I'll multiply by the conjugate for the numerator. Multiplied by root of 4 plus h plus 2 over the root of 4 plus h plus 2. So you're multiplying by 1 again. Here you get 4 plus h minus 4 divided by h root of 4 plus h plus 2. So you essentially get here 1 divided by root of 4 plus h plus 2, which is not an improvement in what I've been taught. So honestly, I'd say it's simplified already out the gate, but I could be missing something, but I'm pretty sure this question does not make sense to me. Okay, 7a. I'll do my good ordering again. 7. Rewrite by completing the square. This is like a technique to change a polynomial of degree 2 into a different form from standard form. So right now we have x squared plus x plus 1. And this is equal to let me just quickly Google this. Okay, I'm back. Okay, all you gotta do for completing the square is you have to take half of the coefficient of your x and square that, and then add it and subtract it. So I'll show you what I mean. You gotta do x squared plus x, so then you have plus 0.5 squared, which is 0.25, and then you have to subtract it from here, so it'll be plus 0.75. And then you have x plus 1 over 2 squared in here, plus 0.75. So that's what they mean by completing the square. It's trying to turn these two terms, or these two terms here, into a perfect square, like this. So then you get into a form like this, where it's a square plus a constant. I'll show you again for b. For b, it's going to be 2x squared minus 12x plus 11. So you got to remove the 2 first. So 2x squared minus 6x plus 5.5. Okay, then you complete the square, so it'd be 2x squared. It's gonna be half of this. So negative 3 squared is 9. So plus 9. Then you have a negative 9. So negative 9 plus 5.5 is negative 4.5. Or negative 3.5. Right. 5.5. 4, 3, 2, 1, 0, 1, 2, 3, 4. Is that how it works? That's definitely 4. Let's say I only had 1 cup of coffee today. 4.5. Oh, it is 3.5. It's 3.5. Yeah. Because if you add 4 to this, you get 0.5. Then you add 5 to it, you get 5.5. So it's just confusing because you have a negative half and a positive half. Okay, that's cool. It's the first time encountering that, strangely. Okay, so this is what you get. At least in mental math, my first time doing something like that, I think. That's pretty cool. Okay, you get 2. So now you can turn this into a square. So you have 2 times... Oh, the 2 also applies to this. So 2 times x squared minus... or x minus 3 squared minus 7. And that's what you get there. Okay, that was a bit tedious. Very cool. I'm gonna get some water and I'll be right back. Okay, we're back. Now we have question 8. Solve the equation finding only the real solutions. So 8a x plus 5 equals 14 minus 1/2 of x. This is a really easy one. Just have a degree 1 polynomial. So you have 1.5x equals 9. So x equals 9 over 1.5 equals 6. Okay, 8b. Two x divided by x plus 1 equals 2x minus 1 divided by x. So you can turn this into a polynomial. Just multiply. You have 2x squared equals 2x minus 1 times x plus 1. Okay, then you multiply this out. 2x squared equals 2x squared plus 2x minus 1. So you can remove this from both sides. 0 equals x minus 1. X equals 1. Boom, easy. You can see x squared minus x minus 12 equals 0. So this way you can factor it out the gate. Be 0 equals x minus 4 x plus 3. Because you know 3 times negative 4 equals negative 12, and 3 plus negative 4 equals negative 1. So just by looking at it, you can just kind of think of two numbers that work like that. D, 2x squared plus 4x plus 1 equals 0. So you have, in this case, you can put a 2x here, a regular x here, and try and find something that works. So you have, has to be 1 and 1 in the last one. So it can be 2x plus 1, 2x plus 1. Yeah, it doesn't work in this case. So let's use the quadratic equation because we can't think of anything readily here. X1 and 2 equals negative b plus minus square root of b squared minus 4ac divided by 2a equals negative 4 plus minus 16 minus 8 divided by 4. Yeah, that's why it's the root of 8. That's why it's being, that's why I couldn't think of it, because it's negative 1 plus minus root of 1 over 2. I believe. Because root of 8 divided by root of 16 is root of 1 over 2. So that's the two answers. It'd be 2x minus 1 minus root of 1 over 2, and 2x minus 1 plus the root of 1 over 2. So that's one you need the quadratic formula for, unless you like autistic savant, which I apparently am not. Okay, D, E. You have x to the power of 4 minus 3x to the power of 2 plus 2 equals 0. Okay, so here you're going to have negative 2 and negative 1 work for this one, but it's going to be x squared minus 2, x squared minus 1. And if you recall, you can expand this further to x minus root 2, x plus root 2, x plus 1, x minus 1 equals 0. Okay, then we have f. 3 times the absolute value of x minus 4 equals 10. So absolute value of x minus 4 equals 10 over 3. So we know that x will equal this is 3 1/3. So 7 1/3 works, and if it equals 2/3, it works. So x equals 2/3, because 2/3 minus 4 is negative 3 1/3. But then you absolute value it, so it's positive over 3. And it will also be 7 1/3. Because that minus 4 is just 3 1/3. So there you go. G, you get 2x times 4 minus x to the negative 1 over 2 minus 3 times root of 4 minus x equals 0. And what do you get here? You get 2x divided by the root of 4 minus x minus 3 times the root of 4 minus x equals 0. So if you want to add them together, you have to multiply this by root of 4 minus x divided by root of 4 minus x. So just skip a step, you can just do 2x minus 3 times 4 minus x divided by root of 4 minus x. Then you can just multiply it out. Equals 0. This equals 0, so as long as, so now we know x can equal 4. So you can get rid of this. So now we have 0 equals 2x minus 12 plus 3x, but x equals not 4. Because you can't have the root of 0 in the denominator. So we have 5x equals 12. X equals 12 over 5, which is not equal to 4. So we get x equals 12 over 5. Very cool, very cool. Okay, on to 9. Solve each inequality, write your answer using interval notation. Okay, negative 4 less than 5 minus 3x less than or equal to 17. What do you get there? What do you get? We can add 4 to each and every one here. So you get 0, it's less than 9, it's less than 3x, it's less than or equal to 21. Then you can, so 0, it has to be greater than 0. So now we're going to, actually no, we want to get rid of, we want to isolate the x. Let's subtract 9. Negative 9 is less than negative 3x. It's less than or equal to 12. Divide by 3. Negative 3 is less than negative x. Is less than or equal to 4. So when you multiply by negative 1, negative 3 times negative 1 is 3. And negative x times negative 1 is x. So Yeah, let's say we plug in x equals 1 right now. So -1 is greater than -3, true, and is less than or equal to 4, true. But if it were 3, 1 is not greater than 3. So when you multiply by a negative, you have to flip all the signs around. So it would be 3 is greater than x, which is greater than or equal to 4. And that's the final answer right there. Hell to the yeah. We're on to B now. B, we have 9b x squared. 9b is less than 2x, which is less than 2x plus 8. Pardon me. X squared is less than 2x plus 8. So here we have 0. It's not less than 8. Let's go for 1. It's not less than 10. 2 is not less than will be 4 is not less than 12. So we can make a table to determine the point when it starts being less than. So really you're trying to solve the equality. So let's just do, instead of this, solve x squared minus 2x minus 8 equals 0. Solve that instead. This would be -4 and 2. Equals 0. The x minus 4, x plus 2. So we know when. So with a case like this, either it's going to be this is only true between -4 and 2, or it's only true when it's not between -4 and 2. Because it makes a problem. So when we already determined that between -4 and 2 it's not equal, or between +4 and -2, pardon me. So let's put in 4 and see what we get. At 4 we get 16 is less than 16, which is not true. So as long as, so here we get x is less than 4, or x is, or less than 2, or x is greater than 4. This is the range it'll be good for. Okay, now we go to C. Which is 2x minus 3 divided by x plus 1 is less than or equal to 1. Which goes to 2x minus 3 is less than or equal to x plus 1. You can subtract x from both sides and add 3 to both sides. So you get x is less than or equal to 4. And that is the solution. Very easy, that one. That was E. That was C. So actually that was E. Okay, let's go to C now. God, man, I'm rusty. C is x times x minus 1, x plus 2 is less than 0. This is the degree 3. This is going to be 3 ranges. Let's do a test point. let's say when x is equal to -3. So you get -3 times -4, which is 12. -12, which is not greater. So we know that when it's below, so x is greater than 3. It's greater than -3. Okay, now let's do when x is at -1. So you have -1 times -2, that's 2. 2 times 1 is greater, so we know that it is when x is greater than between 2 and 0, or between -2 and 0, so that is true. So x is less than 0 and greater than -2. So now we have even better case, it's better than -2, so we don't need this anymore. Okay, now we can do the region between, because sometimes you can have in a degree 3 polynomial, you can have a double root, which we don't have here actually. So I think we can guarantee that it won't actually be greater than 0 in the region from 0 to 1. So now we can just say, or x is greater than 1. Let's just test it out. When x is greater than 1, they're all going to be positive, so you know it's greater than 0. But when x is, let's say, 0.5, you get 0.5, which would be positive, 2.5, but -0.5, which is negative, which is not greater than 0. So, because there's no double roots, you can kind of just know, if you know one region, you know all the rest. And I'm going to do videos eventually on each one of these problems in more detail, but this should be all stuff you already know for calculus. But if you need like a pre-calc course, leave a comment and I'll go through each and every one of these 10 diagnostic algebra questions, and I'll do them in like extreme detail so you can comprehend all this stuff and be ready for calculus. So leave a comment if that's the case. If not, we shall continue. Okay, on to 9D. 9D, we have the absolute value of x minus 4 is less than 3. So, it's funny, they gave like much more challenging problems for A and B. C was trivial. C was a little bit hard. D seems not that hard. But let's do it. Okay, so we have the absolute value of x minus 4. So there's a way to convert this into a equality. So let's just say you have the absolute value of x is less than 1. So we know that, so when x is -1, or x is -2, it'll actually be greater than it'll actually be turned to a positive. So as long as so it's pretty much saying x is not between -1 and 1. Or x has to be between, because it's a less than, it has to be between -1 and 1. So it's just saying x is, so you can just add a lower bound onto it, and that's how you convert that to that. And since x minus 4 is within the thing, so within the absolute value pipe brackets, as they're called in Python programming, the pipe. I'm not sure what they're referred to in mathematics aside from absolute value, but I think you can call them the pipe bracket, get away with it. So it would be -3 is less than x minus 4, which is less than 3. So just to verify that this is actually how it works, let's say we have x equals 10. So 10 minus 4 is not less than 3. So we know it's that was bad. That was a bad example. Let's do x equals 2. So 2 minus 4 is negative 2. Absolute value of that is going to be less than 3 because 2 is less than 3. And here it also holds. And if you push that to, if you keep increasing that until it fails, it'll fail exactly at x equals let's say x equals 1. So at x equals 1, you have 1 minus 4 is negative 3. That's where it fails. So all I'm trying to validate here is that even if you have x plus or minus something, you do the exact same thing as you just kind of expanded and you have the lower bound now. So yeah. So now because we have the absolute value removed, you can't add or remove numbers from it when it's in when the absolute value bracket's there. But once you convert it to this form, now you can remove the 4 obviously. So now what we have is 1 is less than x, which is less than 7. So that's how you solve that one. My screen's really dirty. Okay, 10a. Again, I'm not happy because I like when you have 10, then you have the question written out. State whether each equation is true or false. So, state whether each equation is true or false. And I'll put a colon there. Now we have a and a bracket for the 10. Okay, that's how you present stuff properly, my friends. P plus Q squared equals P squared plus Q. This is not true, but this is what it's saying. So we proved this is not true before. It has to be negative here for the binomial expansion. But we can clearly see it's not true like this. This is equal to P squared plus 2PQ plus Q squared. And you have P squared plus Q squared. So you get 0 equals 2PQ. So, yeah. So in general, P and Q are not equal to 0. So this is false. We're trying to prove is it true in all cases. This is not true. It's only true in one case where P or Q are equal to 0. Okay. But not both. If one of them is 0, it's valid. If both of them are 0, it's valid. But if not at least one of them 0, it's invalid. So it's false. Okay, 10b. Root of AB equals root A, root B. This is true because when you have a square root, you can combine them. So you just put them both in there. Or you can take them both out. So, yep, true. It's just a property of radicals. C, root of A squared plus B squared equals A plus B. So this is not true in general. Let's prove that. Let's square both sides. So you get A squared plus B squared equals A plus B. Oh, wait, what did I was taking on the first page? Oh, okay, never mind. This is exactly what we have in question A. So false. You can take a previous proof and be like, see proof A, and develop it to that point, then say, okay, now see that, therefore it's false. So like higher up mathematics, that's what you would do. But this is only like a 2-line thing, so yeah. But if you have like if it's like you get to this point, but to go from this to proving it false is like 100 pages of proving it, but you would just be like, okay, it's false by the book this guy wrote. Would be what you do in like real PhD mathematics. But not that this isn't real, but you know, in this level, it's not that hardcore. But you know, keep studying, and eventually you'll make it to the hardcore leagues, and I will gladly engage in math battle with you. Okay, BCD. 1 plus TC divided by C equals 1 plus T. So multiply both sides by C. 1 plus TC equals C plus TC. So 1 equals C. This is only true if C equals 1. And because we're trying to let every variable vary between negative infinity and positive infinity, we're assuming the real numbers in this case. Just assuming that. Or complex, but really just in general, we'll just say it's just real numbers. Because you could be like, oh, what if these are actually like 10 by 10 matrices? It might change a little bit, but again, this does not involve any matrices. This is just purely real numbers for now. Maybe complex, but this applies to complex too, I believe, but I'm getting carried away. So unless C equals 1, this equation is not true in general, so we're going to say false. E. 1 divided by x minus y equals 1 over x minus 1 over y. So again, my gut feeling says this is very not true, but let's prove that. And I'm actually 100% sure this is not true, but let's just develop it. So you'd have y over x, y. Actually, wait a minute. You have y over xy minus x over xy. This is a weird way to solve this. So then you have 1 over x minus y equals y minus x over xy. So it's saying xy is equal to y minus x, x minus y. Wait a minute, what is this equal? It's equal to yx minus y squared minus x squared minus xy. This is saying xy equals negative x squared plus y squared. So I mean, this is not true in general. Let's say x equals 0. 0 equals negative y squared. So y has to be 0 also. So let's say, yeah, so I'd say this is false in general. I think really all they're trying to say is, yeah, you can't combine a fraction like this, you moron. This is not how you subtract fractions, but pretty sure that's all they're trying to display here. I've developed it to this point, and I'm going to say it's false in general. Yeah, but I thought maybe it'd be like a trick, like just for whatever weird reason, this actually you can't turn this into this, but no, definitely not, because I would have known about that. So yeah, it's false. Don't do that. Very bad. I think that's everything. Oh, we have one more actually, F. 10F. Then we can go through the solutions. 10F. 1 over x divided by a over x minus b over x equals 1 over a minus b. Okay, so this seems to be maybe true, but shortly you'll realize it is not true. So you times both sides by... Oh wait, no, actually this is true, this is true. Look at that, it's true. So if you have to say x equals not 0, but then you get... Because you multiply this by x over x, you get 1 over a minus b equals 1 over a minus b. So you get this is true, but x is still present in this equation from here. So you gotta just remember that x can't be 0, because you can't divide by 0. So this does equal this as long as x is not 0. So if you had like a function of 3 variables, like a function of a, b, x, and you're like, well, is this function true for x equals 0? It's always no. At least I'm pretty sure that's how it works. But yeah, we'll say it's true. We'll say it's true. Look at that, true. Okay, now for the well, it's been many pages. Let's see how we did. Okay, A, correct, 81. B, negative 81, correct. C, 1 over 81, correct. D, 25, correct. E, 9 over 4, correct. I'm on a roll. F, 1 over 8, boom. 2, 6 root 2, correct. B, 48, a to the 5, b to the 7, correct. C, x over 9y to the 7, correct. Oh, I feel good. 3a, 11x minus 2, 3b, 4x squared. Oh man, I could have further factored this. Okay. Further factored this into what? Okay, we'll redo 4b. We'll redo oh wait, no, never mind, that's correct. I was reading the wrong one. Okay, this is correct. B, boom! Oh, sweet dopamine. 3D, correct. Okay, we're all good then. 3C, a minus b, boom. 3E, x cubed plus 6x squared plus 12x plus 8, correct. 4a, 2x minus 5, 2x plus 5, correct. 4b, 2x minus 3, (3 over 2 and negative 4), yeah, correct. Okay. I just didn't put it in the form. So they're saying when you have this, you can make an equation saying it's equal to x plus 4 x minus 3 over 2, saying you can convert this to this can be converted to, this is also equal to 2x minus 3. This is the same equation. That's pretty cool. But correct. For D, or for C, x squared minus 4, which is x plus 2x minus 2, and x minus 3. Correct. For D, it's my favorite part of the whole thing. It's, x minus 3, x squared minus 3x minus 9. Or plus 9. Oh, we have a mistake. Remember the long division? Okay, the long division. 9x goes into... Okay, negative... x goes into negative 9x, negative 9 times. Okay, we'll redo 4. Okay, 4D is a bit iffy. 4D is a bit iffy. We'll give it a check mark. Okay, 4E. (3x negative 1 over 2, x minus 1, x minus 2). Correct. F. I'll redo all of it when I do the detailed analysis of each of these 10 things to do like a pre-calc course. Well, let's just get into the actual calc. Okay, for F, xy, x plus 2x minus 2, correct. 5a, x plus 2 over x minus 2, correct. 5b, x minus 1 over x minus 3, okay. It's totally not to validate my ego. Was x plus 2 over x squared minus 4. This could have actually been simplified further to, because this is x plus 2, x minus 2. So 1 over x minus 2. So, boom. D, negative y plus x. Yep. 6a, 5 root 2 plus 2 root 10. Yeah, they like that form better. That's like my shirt. It's a Pokemon shirt. 6b is 1 over root of... Yeah, it was already simplified. Oh no, they wanted you to convert it to this form, which is weird. This is what they gave you, but usually you don't rationalize the numerator, you only rationalize the denominator. So that's a weird question. But as an exercise, I guess you can just do it, even though it's not what you do in practice. 7a, x plus 1 over 2 squared plus 3 over 4. Yep. B, 2x minus 3 squared minus 7. Yup. 8a is 6. Yep. It's always like complicated answers in 6. 8b, 1, even simpler, correct. 8c, x minus 4, x plus 3. Yep. D is negative 1 plus minus a half over 2. Yep. E is plus minus 1 and plus minus root 2. Yep. F is 2 over 3 or 7 1/3. So that is correct. 7 1/3 is 22 over 3. Again, I'll get a new camera soon so you can see all this stuff. Just bear with me. G, 12 over 5. Yup. Okay, 9. Solve each inequality, write your answer using interval notation. So I didn't do the interval notation, apparently. So 9a. So interval notation would just be, here we have greater than 3, so you do a curly bracket, or a round bracket, 3, comma, and then x is, wait a minute, yeah, This is messed up. This is messed up. So it's going from -4 to 3. This was messed up. Let's just not go from this step to this step. So what you actually don't do this. You don't flip it like this. This is wrong. It's very bad. This is correct. And you would say it's x is greater than 3 . No, this is correct. Oh, I just forgot the -4. That's all I forgot. Okay, no, this is actually, never mind, this is right. I forgot the negative sign. Ah, okay. 3 is greater than x, which is greater than or equal to -4. Okay. I forgot the negative on the 4. Oh, those silly mistakes always get you. So this is correct, and you would say this is greater than or equal to -4, which is square is greater than or equal to -4, and then less than 3. So that's how you do that in interval notation, which is what they want. Okay, B would be greater than 4, less than 2. Or less than -2. Right? This is saying the opposite. So let's say when I put in x equals 0. Oh wait, this is actually true. Okay, so this is the opposite then. Okay, so this is actually greater than and less than. Okay, I gotta review this. X is greater than -2 and less than 4. It's a course for me and a course for you. We all learn stuff here. We all learn stuff. Boom. I got it right. E. 9E. It's less than or equal to 4. Okay, clearly I'm not up to speed on these things because these answers are not agreeing with me. Less than or equal to 4, yeah, but it says it can't be above -1. It can't be below -1. With -100 over negative. No, this makes no sense. It can always be below -1. This is hooey. It's correct. Load of hooey. Okay, 9C. Yeah, this one's correct. -2 to 0 and greater than 1. So that's correct. Right, so I mean, this one's correct. D, 1 to 7. So that's correct again. I like it. Get up 10A, false. 10B, true. 10C, false. D, false. E, false. And finally, F was, in fact, true. Okay, there we go. So it's all pretty good. Little bit of a hiccup in the alligator mouth zone. Slight forgetting of a negative sign in one of the questions. Other than that, this should all be known for pre-calc. And then now you're ready to move on to calc. So if you have any questions about any of the stuff, leave a comment. If you want any private tutoring, give me a email at the email below. If you need paper, pens, the textbook itself, I eat these like caffeine mint chocolate bars while I do math, really helps me out. Or I take this stuff called Siltep. It's kind of like a nootropic. You can find all that in the links below. And, thank you for watching. Good luck in your math.